I don't know how many folks use Node.js. Obviously, we are very strong believers in Node here at Joyent. And when Dave was demoing the implementation detail of Cartlytics known as Manta, Manta is essentially all written in Node, and then see if the operating system fits. So we are very strong believers in Node and use it heavily in production here. So Isaac, take it away.
All right, thanks. This is a little bit further up the stack, I think, than some of the other system stuff you've heard about. But like, how many people use Node? I wasn't actually looking. Okay, that's like most people here. So raise your hand if you've used streams in Node directly. Okay, that should be almost everybody who's used Node, because it's actually almost all of our APIs are streams. So I want to talk about some mixed metaphors. This is this is what most people think of when you use the word streams. They think of like, oh, it's like flowing really fast, and that's kind of what happens when you have water in in a hilly place. It collects at the lowest possible place and then all goes in a channel, which we call a stream. But really, streams in programming parlance are not very much like this. They're more like something with stoplights. It's more about actually slowing down the flow so that you don't get what you get with streams of water, where when there's too much data, it overflows and you have problems. So the earliest sort of implementation of streaming data in Node was something that we kind of hagiographically refer to as Stream Zero, the Stream Zero API, which is basically not any kind of consistent API. There was just like these different things. So HTTP requests would have an on-body event, files would have data events, and then they would have an EOF event when it was the end of the file, because obviously that's what you call the end of the file, right? Like, why would you call it end? You call it EOF, that's the name. The problem, and like that kind of made sense as we were sort of figuring out these things in Node, but the problem with that is it makes things very unnecessarily different when they're doing basically the same sorts of activities. So the first Stream API was relatively simple, and we ended up with a pretty good amount of consistency. So readable streams would have data and end events. They had pause and resume methods. And then writable, on the writable side, we had a write method that would return true or false, depending on whether the data was completely flushed out, and thus you should, keep writing more data. And this is actually what was our like stoplight. So you could pause a stream when your writer was kind of backed up, and then once it drained, you could put more data through. Also, we added this thing called the pipe method, which mixes our metaphors and makes even more water-related things that are actually not very good metaphors for flowing data, by adding all kinds of plumbing metaphors. And what's great about this is that it let us like plug a lot of different pieces all together that were not really intended to work together ahead of time. And this is like led to this big explosion of streaming APIs in Node that you could hook together like Legos. And so the metaphors are going to just keep getting more and more mixed. I'm sorry, it's really bad. Naming stuff is hard. There were some problems with this, which, and I think the one lesson you'll probably hear a few times is that you really don't find out about the problems until you just go and do something. And then go, oh, well, that sounded like a really great idea. It turns out it sucks. And one particular, the biggest problem is that the pause method doesn't actually stop data like right away. So you couldn't like, let's say, pause an HTTP request and then go and make a request to your database and do some like stuff to figure out who this user is and come back and then decide how to handle it, because you would end up missing a data event. And so that led to everybody having to write these buffering streams implementations that would like, when you press pause, they would when you call pause, they would actually pause and would buffer things up in memory. It turns out this is actually really easy to get wrong. And if you look at the history of computing, I guess in general, like, hey, I've got a whole bunch of data for you. You're not ready for it yet? Okay, we'll like figure out how to do the right thing. It sounds really straightforward when we're talking to people about it, but then when you sit down and actually do it, what you find is there's all these edge cases that are just kind of gnarly to deal with. And so it led to some very unclear semantics about, like, you know, when certain streams would automatically pause and would buffer up to a certain amount, other streams would just give you data even if you said you didn't want it, and expect it to be your problem. And also there was no extensible base classes, so all the userland streams were kind of a mess and would just have, you know, completely different ways of doing things. And so it was more like this, where you have kind of this gnarly mess of stuff. In particular, if you had one readable stream that you piped to multiple writers, a really terrible thing could happen, which ended up being a pretty gnarly bug in Manta. And if I hadn't just fixed it in Node core, Mark Cabbage actually pinged me and was like, hey, we're having this like crazy problem. We can't figure out why we're running out of memory. I was like, oh, hey, I just fixed that bug. Okay, like write a little thing for you. It took me like a half an hour because it was actually pretty straightforward, but it's like you have to know all this crap and all of these like semantics and edge cases, which are really, really problematic. And basically what would happen is if you, just to back up a step, when you pipe to two different readers, you would pipe a reader to two different writers. You would write to those two different places, and let's say one of them gives you a false response, indicating don't write any more data to me. Well, the other one might emit a drain event, which would trigger you to start flowing data again. And so if the slow one keeps getting stuff written to it, and the fast one keeps emitting drain events, then you end up filling up your memory with all this data. And you know what you really want to do is keep track of like how many things am I piping to, and how many of them have told me that I need to wait for a drain event, and just know that you have to handle this. So fixing the problems ideally, unfortunately, it was not actually an option at the time, because a lot of programs were built based on these certain semantics, and sort of intentionally or not had come to rely on them. And it turns out backwards compatibility, if you're a platform, is one of the most important things. You know, we had people actually building like, you know, these weird kind of edge cases are all tied into the guts of how their programs work. So we took between 0.8 and 0.10 of Node, we took quite a bit of time and dug into this. It took, you know, as is often the case in software, it took about 6 months longer than I thought it would. But in the end, we, you know, with a lot of work from a lot of different people, we kind of tracked this all down, and we wrote Streams 2. So the Streams 2 API changes things somewhat from a push model to a pull model on the readable side. So we have this readable event, which emits to let you know. It's really easy to walk in front of that thing. Which emits to let you know that there is data you can pull out. And then there's a read method which takes all that data out of the stream. Multi-piping works. We added extensible base classes so you could create your own writer or reader, and it would do everything exactly correctly. And there's even a compatibility layer which we added so that if you add a data event, it switches into old mode and just starts throwing data at you. There were some problems. First of all, it was just a massive refactor. You know, the more lines of code you change in any kind of platform, the more stuff you're going to change without realizing it, the more userland programs are going to break as a result. No matter how hard you try to make that not happen. There was also a couple of cases where there were performance issues which required us to keep some like oddball, even pre-Stream 0 kludges that were kind of living in the HTTP.js guts. There was no way to passively listen to a stream, so if I have a reader and I have a writer and I want to like draw a progress bar on the screen or something, right? Like I don't want to do anything with that data, I just want to see when it passes through. There was no way to do that without switching your stream into old mode, and old mode, the compatibility mode, was a one-way switch. So what would actually happen is the pipe method would get changed to some other pipe method, which was not the pipe method that you had in the beginning. I told you, the metaphors are bad. They're bad. Keep saying that. So recently we've done, with actually very little fanfare, what we've been calling Streams 3. And basically, when you take the API of streams 2 and the API of streams 3, or the API of streams 2 and the API of streams 1, you get streams 3. This is by the way, the character's name. It's a pike. So it's the so no, instead of the it's literally like the overlap of those two APIs. So instead of having a flowing and a pause, instead of having an old and a new mode, we have a flowing mode and a pause mode. So you can actually add a data listener, and that'll start data coming through. And then you can call the pause method, and that will pause it. And now some other user of this stream, you can hand that stream object off to someone else. They can call read, they can listen for readable events, they can do everything that they could do with streams 2. Also just enabled us to, in the process of going through this, we were able to focus on some of the performance regressions that had happened in streams 2. And even there's an open pull request right now, but we'll probably get that landed soon, that allows us to remove some of these kludges from the HTTP implementation, which is really nice. So, if you look at the socket that the HTTP server is interacting with, it's just a normal TCP socket. It's not like this kind of jerry-rigged, like, different thing. The other thing that was kind of a compelling motivator for landing the Streams 3 API patch was that a lot of people, when I explained to them how this would work, they said, hey, isn't that how it happens already? Like, well, that's stupid that it doesn't already do that. And so yeah, it works how people apparently thought Streams 2 worked, which is nice. And with the data events now, you can actually have that passive listener type of thing. Oh, thanks. Other just, minor thing that got added, a pretty big deal, was that we added a cork and uncork method to the writable API. So with that, if your stream implements write v, which is like an interface to the write v syscall, if that makes sense for that particular type of stream, you can call cork, do write, and then uncork, and it'll take all those writes and send them as one syscall. So for HTTP chunk decoding, that is really awesome, because we do all these stupid things where we have like a tiny, like a 2-byte thing saying how big of a chunk it is, and then the chunk itself, and then the end of it, and like you end up with all these tiny little things. If you're sending each one as a separate write over TCP, that's like a TCP round trip for what? For 2 bytes. It's stupid. So you take the chunk and you take the little header that says how big it is, and you have to kind of concatenate them. You end up with encoding issues, and if that requires a full copy, then it only makes sense if it's like above a certain size, and you end up with like these magic numbers littered throughout the code. It's a big mess. So using write v is absolutely the right way to go here. So the problems with Stream 3, unfortunately, I don't know what they are yet. We will find out when I drop 0.12 on all you guys, and you have to suffer with them. But yeah, 0.12 should be a really nice Node version compared with 0.10 or 0.8. And basically that's where we're going to find the issues prior to 1.0, because the plan thus far is just to have 0.12 be sort of like the preview release of 1.0. We're going to give it a few months, do some performance and stability fixes, and mostly not change the API throughout that entire cycle before 1.0. So beyond the obvious, like, why is this, and obviously the fact that I work here, like, why am I talking about this here at this meetup? I think an important takeaway of this is that systems are, when you consider the entire system, you're spending a lot of time actually looking at the application. And applications are built on top of platforms, and they're assembled out of these libraries that are using API patterns in order to be interoperable with one another. And a lot of the performance and usability problems that we've encountered in Node actually come out of these core API patterns. And I think that it's very applicable to other sorts of systems as well, where you have APIs and patterns that are used throughout the system. If there's problems in that, then that can be a good place to kind of focus your attention and optimizations, because it's going to yield big benefits throughout the entire stack. and it's often difficult to see the forest for the trees, so it's good to kind of, work at a high level and a low level at the same time, which I think is a big aspect of doing systems analysis and systems programming in general. So that's it.
Thanks, Gene.
Have any questions? Thanks. Yeah.
So I'm curious. Streams. What's the implementation detail there? Is it like arrays? Is it like linked lists, or like did you have to manipulate a lot of those internal data structures to like make this change, or?
So the implementation detail for readable streams in Streams 2 is that it's there is an array of chunks, and every time that data becomes available in the implementation, it calls a push method, which pushes that data onto the internal buffer. And every time you call read, it pulls data out of that internal buffer. The implementation detail between Streams 2 and Streams 3, we changed the way that pipe works so that it actually works based on a data method, or sorry, a data event. And every time you call read, it emits a data event. So that enables us to do passive listening, and it also enables us to have this flowing and non-flowing mode be, well, when you push, if I know that you're flowing and I know that there's nothing in the way of it, then I can just go ahead and emit the data event without having to go through that internal buffer event. So that saves us a lot of event emissions, and it saves us some array juggling.
And did you have to work with this in C++, or is this all in like the userland space of JavaScript, or?
Okay, so yeah, it's 100% in JavaScript in Node Core.
Okay.
So it's the term userland in a kernel OS userland kind of sense means, is it in the kernel or not, basically. In Node parlance, there's Node Core and then there's userland, where userland is like stuff in NPM and Node Core is all the stuff that's compiled into the binary. In this case, it's entirely in Node Core. It's in the lib/stream.js stuff. Anybody else? Yeah.
When you were designing these APIs, probably every platform that's ever existed has had to design some I/O APIs, some sort of reader-writer concept. Did you go look around at what other folks had done and sort of pick and choose? Did you just start from scratch? And if you picked something, if you got ideas from somewhere else, like where were they? I'm just curious about that process.
So the biggest motivation so there's two things. Like, one, it's like, where did you go and borrow stuff from? And then the second, ridiculous constraint is like, what changes were we able to make without breaking everybody's NPM libraries? So that actually constrains the problem pretty significantly, and it doesn't leave you a lot of room a lot of wiggle room. But the biggest motivation for Streams 2 was actually the read, ePull, and eWoodblock kind of API, right? Where you pull on a file descriptor once, and you get some notification that it's readable. You call read until you get an error that says, sorry, I can't give you data right now because that would block. And then you go back to waiting. And that's kind of like the readable event and the read method, and then read method returning null when there's no data. Also, it was a pretty straightforward way. There was a pretty straightforward way to kind of take that and wrap it in a Stream 1 kind of API layer. The motivation for Streams 3 was just like, well, how do we make all these things work that currently suck? And how do we kind of like make the modality less of a pain in the ass to deal with? There is actually some very interesting work being done by What Working Group about getting streams in the browser for stuff like, a smarter XML HTTP request, or like, what's the remote peer-to-peer data thing? WebRTC. Yeah, WebRTC stuff, so that you can get chunks of data through WebRTC with some kind of consistent API. So with the constraint of backward compatibility somewhat lifted, it's kind of nice and also kind of not so nice, because on the one hand, like, that gives you freedom to do more interesting things. On the other hand, it gives you freedom to like walk around in circles and just do whatever and like scribble on a drawing board forever. So that the constraint of keeping backwards compatibility is actually kind of limits your choices to the point where it's relatively easy to just pick the best one.
Isaac.
Yeah.
In the days of Pope 1, Ryan Dahl, he tried write V and found it to be the same fast, if not slower, and lots more complicated. What's different now? Why is it faster and better?
He tried to write what?
Write V. Like, so he did a write V implementation, and he was like, oh, it's roughly the same speed, but it's way more complicated, let's not do it.
So, there are a few things that are different. One is, we had already kind of abstracted out the stream API layer, which he hadn't. So he was doing it in a way that had to be applicable to multiple different streams that didn't have any kind of base class. The second thing is we're like, 2 years or a year and a half worth of V8 iteration, and like JavaScript objects are just faster to use now. Another thing was I think he was doing something silly with string encoding because we didn't have buffers at the time, or we didn't have, no, there was a low-level V8 API that we have now for writing strings that he didn't have at the time. So you had to keep references to the strings around, so that sucked. So the write V stuff though it's nice. It is actually significantly faster if you are on a path that's doing a lot of chunk encoding, right? Voxer will like it.
Like live audio over HTTP?
For example.
For example.
Yes, Nisha.
How have the benchmarks shifted with Streams 3?
How the benchmark shifted with Streams 3? Not much. The benchmarks have shifted tremendously because we're on V8 3.20 instead of 3.16, I want to say. Also, there has been a bunch of libv changes that have changed the benchmarks considerably. So basically, like, there are a couple of use cases where it's like 2,000% faster, and it actually is 2,000% faster because, like, better V8. I am. There's also a couple of cases where it's like a little bit slower, maybe than 0.10. So we need to kind of figure that out. The differentiation between like Streams 2 and Streams 3, though, no significant difference. The big win there was that when you push something and you're already in flowing mode, it'll just emit the data event right away rather than going through the buffer. And so there's a couple of code paths that got faster as a result of that. Otherwise, yeah, almost no change. I mean, most people won't notice Streams 3. I think you had a question. Yeah.
Just a quick one. You were talking about the sizable constraint that backwards compatibility imposes. And I'm wondering, so you sort of kept that constraint for now. Do you ever anticipate deviating?
Do you ever anticipate deviating? So, anticipate deviating from backwards compatibility in a significant way?
Yes.
Not and still call it Node. I mean, all software is great, and all software programmers make decisions that make lots of sense at the time, but there will never be a Perl 6 or a Python 3 of Node. Like, I think that the responsible thing to do there is to give it a new name.
Padua issue.
Yeah. I mean, like, the responsible thing to do if it's a new language or if it's a new platform is to pick a new name, like a gentleman, and make a new project. Yeah.
Is this where no comes in?
Yeah. Or, give it some other kind of name.
We do demerit for trolling at Joyent, so you may end up walking away with some demerits if you troll Isaac about.
I actually kind of enjoy being trolled.
We all do. That's part of the problem. We're all addicted to being trolled.
Yeah.
Any other questions for Isaac? Or
I have a quick one.
yo, sorry.
What's your sense of the adoption of Streams 2? Do you think the developer community is full to accept it up, or is there another?
Yeah, I mean, well, the nice thing about Node is that it's growing really fast. So, and people who are new to something will just crack open the API docs of the latest stable version and do whatever it says to do. So
It's also remember that Streams 2 and Streams 1 are very similar in a lot of important ways for a developer. A lot of us have got software that runs on both 0.8 and because of all the work that Isaac did to ensure backwards compatibility. I mean, you can get a lot of advantages of Streams 2 with pause working the way you think it should and so on, without having to change your mindset.
I think if you do backwards compatibility right, and it's not 100% backwards compatible, it's like 99% backwards compatible. So there was a few like notable cases where it was actually kind of a pain and people had to go change their code. But to the extent that you do actually maintain backwards compatibility, adoption's not really an issue. Like everybody has already adopted it because they're writing code that it's compatible with. As new users come onto Node, they're going to just assume that things work with Streams 2, and if they don't, they'll be, sending pull requests and issuing bug reports and so forth. The bugs and issues that we've gotten about it have been, noisy enough to motivate writing Streams 3, which is not a rewrite. It's just like some relatively minor shifts and polish. And I think it's mostly been pretty well received. People get annoyed when they have to change a program. Like if you write something and then you upgrade Node and now you have to change it. God, I wrote that a year ago and I don't even remember how it works. Now I gotta open it up again. You're a jerk. And like, that's always gonna happen. But there hasn't been that much of that. Yeah.
I do release engineering, so a lot of them. At what point do we essentially say there's a lot of things that would be nice to fix, but maybe we actually say, no, there needs to be a 1.0 release of Node itself that's stabilized the truth. Because Streams 3 is nice, it's in addition to the API.
No, it's actually not.
Isn't it?
It's somewhat of a reduction of the API. Actually, we've reduced out a few bugs.
Well, no, you're still changing the actual API that you have to use 3.
The API changes a little bit.
So the point being is that at some point you have to say the API for 1.0 is this.
That's what 0.12 is.
Right, and that's what Isaac said is that 0.12 is going to get stabilized, and then it's 1.0.
Like, if we had a lower barrier, if we had a lower bar for what could count as stable, we could have probably called 0.8 1.0.
Well, yeah, that's a.
But I can tell you that as a company that has been building things on Node since 0.2, we are very clearly asymptotically approaching stability. You look at that. Streams 2 is a very heavy piece of lift, and the actual effect on the code was actually surprisingly minimal, given how big it was. Versus some of the changes from like 0.4 to 0.6. There have been.
0.4 to 0.6 was a nightmare.
Thank you. I didn't want to use the nightmare word, but yes.
I'm not saying we have to progress. The point being is that at some point we need to be able to tell the developer community we're on this particular release for stable, for truly stable. Things haven't changed. We will do bug fixes for this. As a community, we'll do bug fixes against that API.
Well, see, and you know that Node always does this with even numbered releases.
Yeah, even numbered releases
are exactly that.
Within the even numbered release, they're exactly that. If you have a system that you released with 0.10.0, it should still work with 0.10.99. There are obviously some cases where you could be using some internal API or some weird edge case bug, and okay, there will be some changes. But in terms of the API, there's not even any API additions within a stable release.
There's not even V8 upgrades generally, unless they're V8, critical V8 bugs.
They're V8
V8 patch version. So it's like things within a stable range, things stay pretty stable. But anyway, can we? I want to. Yeah, exactly. Thank you. Thank you, Isaac.